Hey guys, so this video we're looking at solving linear inequalities, and the first thing is to understand what inequations are and inequality signs or inequality symbols. Okay, and so anything that is, I guess, anything that equals is going to be that. Okay, so that's an equation because one side is equal to the other side. So if A is equal to B, then it's an equation. Okay, but anything that is not an equation, you're going to have A is not equal to B. Okay, another option is that say A is less than B, or A is greater than B. You could have A is less or equal to B, and finally you have A is greater or equal to B. And so, for example, if we changed all of these numbers from B to, let's say, 5, okay, so we're going to just illustrate how A represent numbers that are less than 5. So as an example, we've got 1, 2, 3, and 4. Okay. Any numbers that are greater than 5, examples could be 6, 7, 8, 9, and 10, and so forth. But what we have here, so this is what we call exclusive symbols. Okay. So they're excluding the 5. And when we use with a number line, we're going to use an open circle. Okay. But these two symbols here are more or less the same, but just a slight difference. We've got the line underneath. It's saying that A represents the values that are less or equal to 5. In this case, it's going to be 1, 2, 3, 4, and 5. Okay, so 5 is now included. And then so the same thing goes for, whoops, sorry. Yep. So with the next one where A is all the numbers that are greater or equal to 5. So we're going, it's 5 as well as 6, 7, 8, 9, 10. Okay. So these are inclusive because they are including the number 5 as the reference point. And we're going to be using the solid point. So you would have seen this in previous years, okay? And so, for example, if we had the number line here, and this is the number 5, we're going to, what I might do is I'll just represent these with different colors so you can see the difference between what we're working with. So we'll start from the bottom up. So to represent all the numbers that are greater or equal to 5, we're going to have a solid dot because it's including 5, and greater is going to the right. Okay. If we're going with the third one, it's going to be a solid dot because it is including 5, but it's less than. So all the numbers that are less than 5, but including 5. If we go with the second one, A is greater than 5. You have an open circle because it is excluding. It's not including the number 5, but it is all the numbers that are greater than it. And then lastly, we have the very first one. A is less than 5, so it's not including 5, but it's all the numbers below it that we're referring to. So that's just a very quick graphical sense of inequalities. But in this case, we're going to be looking at solving them as well as graphing them later on. Now to solve these inequalities or linear inequalities, it is no different to, I guess, solving normal linear equations. There's just one little concept that you need to be mindful of at the very end to really make sure that you do the right thing. So let's do two examples here. We got 4x minus 1 is less than minus 2. Okay. Now I'm just going to put the symbol up there on the top for the moment, and I'm just going to treat it as a normal normal linear equation. We're going to add 1 to both sides, so we got 4x is equal to minus 1, and then we're going to divide both sides by 4, so you got negative quarter. So when we look at our equation or our number line, just in terms of graphing it, we'll put negative quarter over here, and that's where it is. But we're not dealing with equations here. We're dealing with inequations or inequalities. So they are all less than. So it ends up being x is all the numbers that are less than negative quarter. It's not including that number. So that's how we would represent that on the number line. Okay. Now, if we had a different scenario and we had this case, so 6x minus 7 is greater or equal to 3x plus 5, we're going to solve this as normal. So I'm just going to write the symbol on the top so I don't forget, but just to prove my point that we're not doing anything different for the time being. So I'm going to move the 3x over there, and I'm going to move the negative 7 over there by adding 7 and taking away 3x. So we end up having 3x is equal to 12. Okay, therefore x is going to equal 4. But remember, we're dealing with an inequality sign, so I'm just going to replace that. You don't have to do it as such for me, but I'm just wanting to state the point that I'm just solving this as normal like any other linear equation. So we got x is greater or equal to 4. Here's 4, that's my number line. It is including the number 4, and it is greater. So it's going, we'll put the arrow pointing out the other direction. Okay, let's do a couple more because I'd like to head towards I guess the extra step or the different step that we need you guys to be mindful of. So we got minus 3m plus 5 is less than minus 7. And I'll probably put this example here just to kind of get you to focus on how we expand brackets. Okay. We're going to solve this as per normal. So I'm just going to put the symbol up on the top, make this equal. So I'm going to move the 5 across over here by subtracting 5, and we'll have minus 3m is equal to minus 12. So that means, but because we're not dealing with equal sign, it's less than, minus, we're going to divide both sides by minus 3. M becomes positive 4, but the rule is when you multiply or divide by a negative number, you need to flip the inequality symbol. Okay, so that's a really important thing that I'd like you to put in. So m is going to be greater than 4. And you'll be wondering, why is that the case? You might be a little bit confused. I'm going to rewrite this equation, but without having to deal with negative values. So have a look at this. And in this case, I'm going to move the negative 3m across to that side, and I'm going to move the negative 7 across to that side. So I'm going to add 7, I'm going to add 3m. So what we'll end up having is 12, positive 12 is less than 3m. So 4 is less than m. Okay. Now, if you look at this construction versus that one, you'll notice that the both statements hold true. You're going to have m is greater than 4, okay? And then you also have the same thing, m is greater than 4 over here. But let's say if we hadn't flipped the symbol and it just remained that, then we have two statements that contradict each other. We're saying that m is less than 4, but in this case, when we look at this version, we have 4 is less than m, which means m has to be greater than 4. So please hold this rule closely and be very, very attentive when you multiply or divide by negative values in equations. So I'm going to do another one over here on the right hand side. I'm going to expand, so 5x minus 10 is equal to 7x plus 21. Now, what we'll have is, I'm going to purposely deal with negative values. So I'm going to move the 7x across. So we'll have negative 2x, and we'll move the negative 10 across to that side. So you'll end up having positive 31. Now, I'm going to reintroduce the symbols. Okay. So we've got negative 2x is greater or equal to 31. We're going to divide both sides by negative 2, and we'll end up having x is, and because we're dividing by a negative number, we're going to flip the symbol around. So x is now less or equal to 31 divided by 2, but a negative value, okay, because we divided by negative 2. So negative 31 over 2, or we could say negative 15.5. All right. If the question doesn't specify what format, decimal, fraction, it's really up to you. Okay. Alternatively, I will just show you how to, I guess, not deal with negative numbers. And you'd want to assess the inequation and see how you can keep things positive. So I'm going to move the 5x to the right, and I'm going to move the 21 to the left. So take away 21, take away 5x. So what we'll end up having is negative 31 is greater or equal to 2x. And then that way we have negative 31 divided by 2 is greater or equal to x. Okay, so same statement, but it's phrased in the different direction, but they both remain consistent with each other. And lastly, if you were to draw a number line, so there's your number 4, and in this case here, it's an open circle. M is going to be greater than 4. Okay, so just see which direction m is greater than the values of 4, but not including. And on this case here, we have negative 31 over 2, and x is less than that value, but including that value. All right, if you have any questions, guys, let me know. Otherwise, we're going to show you how what this looks like on the Cartesian plane